All right, so this is number one. So first thing we're going to do is identify the key features for the function of the graph shown. So this one's a little bit weird. It's not like a nice parabola or anything like that. We've got this piece, which kind of looks like an upside down absolute value, and then we've got this straight line constant here. So the first thing we have to do is this time it asks us to find the range first. So remember, the range is the y's, so we have to find all the y values that we have. Now, this is a little bit weird, but we are starting down here at 0. That's the lowest that it gets. We're going to come up here to 2. But then there's this gap. So since there's a gap there, we have to say 0 and 2 first. So we're going to go from 0 to 2. Both of them are going to get the brackets. Even though this is open over here, we're closed on this side, so we can use the square brackets. And then we have this piece over here, which is at the height of 3. So we can also say that we're also at 3. So we're going to union with just 3. So that's what that would look like for the range. Again, if it was all one range together, we'd only have to have one thing. We wouldn't need the u. But since it's two separate pieces, we want to put the u there for the union. The domain, remember, domain is the x's. This one's kind of nice. We're starting over here at -4. We're going to 0. But I don't need to do two separate domains. The reason for that is we start up again at 0. So we don't actually skip 0. And then we go all the way over here to 4. So we're actually just going straight through from -4 to 4. -4 and 4 are both solid dots. So we're good to go with the square brackets as well. For increasing, remember, increasing is always going to get parentheses no matter what. Here we just have to see where we're going up. So in this case, this graph is going up. So this is increasing. This side is increasing. Here we're going down. So that side is decreasing. We don't want to pick that. Same deal with the straight line. This is a constant. We don't want to pick that either. So we're only increasing from -4 out to -2. Remember, when we deal with increasing or decreasing, we're only dealing with the x's. We don't really care about the y's. The x-intercepts are next. There's only one x-intercept. So this is a solid dot, so we have to pick this one. This is open, so there's nothing actually here. It's not actually an x-intercept there. So the only x-intercept I've got is at -4. So just -4, 0. 0, 0 is not one because it's open there. It's not closed there. Last thing we have to do is get the average rate of change from 0 to 2. Remember, these are both x values. This is x1, and this is x2. All right, now with 0 and 2, again, we got to be careful because we have to pick the points that actually exist. And when we talk about 0, this is where 0 actually exists. It's at 0, 0. 2 for x2. 2 is right here, so this is the other point I have to get. This is not 0, 0, sorry. Use the eraser. It's at 0, 3. So we'll write that in as 0, 3. 2 over here, we're at 2, 3. So these are my x1, y1, x2, y2 coordinates, or a's and b's. We could do f of b minus f of a over b minus a. Either way we choose to do it. If we want to do the f's, we can do it like that. F of b minus f of a over b minus a. Remember, a and b are the x's. The function values are the f of whatever. So f of b is just like y2. So f of b is 3. F of a is this 3 over here. y2 minus y1. B is going to be x2, so 2. A is going to be the first one, so that's 0. So 3 minus 3 is 0 over 2. We get 0. There's a slope of 0, and that makes sense. We're not changing at all from 0 to 2. It's just on the constant side. So there's no change here. We're not actually going up or down at all, so the slope would be 0. This average rate of change is the same as the slope. So that's 1 through 5. For number 6, what's the equation for y equals x minus 1 plus 7 reflected across the y-axis? So again, whenever we reflect across the y-axis means we have to change x's to negative x's. So we're going to come up here and change all the x's to negative x's. Y equals negative x minus 1 plus 7. And it turns out A is the choice that we have. That is negative x minus 1 plus 7. So that's the idea, is we're changing the x's to negative x's if we're reflecting over the y-axis. So we're going to reflect that way. Remember, you can always graph it in Desmos and check it out in Desmos if you want. For number 7, 20-gallon tub being filled with water at a rate of 0.5 gallons per minute. The tub originally had 5 gallons of water in it. What is the range of the function that represents the volume of water in the tub after X minutes? So we need to find the range of this one. So remember, range is like the y's. So range isn't going to be the number of minutes. Minutes would be a domain. Range is going to be the amount of water that's in this thing. So we have to find the amount of water. So the smallest amount of water that we can have is not 0 because we do start with 5. So since we know we start with 5, there's only one choice because only one of them has a 5 with an equal sign with it. So the answer is B, and we're kind of done. If we want to check the end, we know the most amount of water we could have is 20. We definitely know we want 20, so we could also just say, hey, this is the only one with the 20 with the equal sign, so we want to pick that one. So that's B. So again, here the range is going with the amount of water. If we were doing domain, then we would be doing the minutes, because minutes is domain, range is going to be the volume. For 8, over what interval is the graph of y equals -2 plus absolute value of x minus 2 increasing? I'm going to sketch this out. I'm going to use my shifts here to say that this is going to move us right 2. So we'll go right 2. I've got a -2 outside the parentheses. Remember, inside the parentheses is left and right, so I know I'm going to go down 2. So 1, 2. And then I know that an absolute value, so with the absolute value bars, I know that's got to be a V. So I can go ahead and just draw a nice little V in. All right, and so now, wait, that wasn't right 2, that was left 2. I wrote right 2, but I moved it left 2. But it's okay, because I caught it, so it's all right. I'm going to go to the right 2. So let's move our V over. There we go. Come on, V. There we go. All right. There we go. Always good to double check. All right. So we moved to the right 2, not to the left 2. That makes more sense. Okay, so we got to find out where we're increasing. So again, increasing is when the graph is going up and to the right. So that's going to be on this branch over here. So this starts at 2, and it's just going to keep going forever. So the one that starts at 2 and goes forever is going to be choice A. So that's how to do that one. Again, if you want, you can graph this in Desmos. You don't have to make the sketch by hand. But just with the shifts, it's kind of nice that you can do it by hand. For 9, we need to identify all the translations of the absolute value of x. That give us 2 plus the absolute value of x plus 3. So again, in here, we got to do the opposite. So plus is going to move us to the left. So we're going to go left 3. So this is left 2, that's right 2, that's right 3. There's only one choice. Okay, well, I guess we're picking A at this point. If we want, though, remember 2 on the outside means we're going to go up 2 because it's a positive 2, it's not a -2. All right. Number 10, we have to graph another piecewise function. So again, this right here, -2 is a constant. So we know we just want to take each of our x values and match them with -2. So 0, -2, 1, -2. This one's going to be closed because it's got the little or equal to sign. This one's going to be open because there's no little or equal to sign. So let's just go ahead and graph those right now. 0, -2, closed, 1, -2, open, and we'll connect it with the line. The bottom equation, I'm going to skip to that one just because it's another constant. It's just another number out here. So this time the number that we've got is 1. So using both of the x's, 2, 1, 4, 1. 2 1's open, no little equal sign. 4 1's closed, little equal sign. So we'll put those in. So 2, 1, and then 4, 1. All right, so far so good. Only one piece left, so that's pretty quick. So we got 3 minus x. So for this one, I've actually got to plug them in. So I'm going to plug the 1 in for the x, and then I'm going to plug the 2 in for x. So if x was 1, if I plugged 1 in for x here, we'd get 3 minus 1 is 2. So my point is going to be the point 1, comma 2. If I plug 2 in, if x equals 2, 3 minus 2 is 1. So I also want the point 2, comma 1. Okay, well, that's kind of nice. They kind of mirror each other. Both of them have the little equal sign, so both of them are closed. And that's fine. There's no rule that says I have to have one of each. So we plot 1, 2, and then we plot 2, 1. Now this is a little strange because we're actually filling in our open circle here. And that's allowed. We can go like that, and that's what the final graph is going to look like. So this ends up filling in the open circle. So that's kind of cool that we didn't have our open circle there anymore. Still have this one, but this one got filled in because another point filled it in. That's kind of cool. That's continuous at that point. All right, for number 11, which of the sequences are arithmetic? Select all that apply. So I can pick more than one, which means I have to check all the answers. But remember, the whole idea behind arithmetic is that you're going to either go up or down by the same amount every time. So let's check. We got 4 to 1, which means I'm going to go down 3. 1 to negative 2 is down 3. 2 to negative 5 is down 3. 5 to negative 8 is down 3, so I'm going to pick A. It's important to check every single one of them. But it's possible that the first couple can do it, and then the last one could be the one that breaks. So you have to make sure you check every single choice. To go from 9 to negative 10, I'd have to go down 19. So I'm going from 9 to 0, which is 9, then down another 10. From 10 to 11, I'd have to go to plus 10 to 0, then plus another 11 is 21 to get to 11. At this point, those are not the same, so we stop. Not going to work out. Over here, 1.0 to 1.2, we're going up by 0.2. 1.2 to 1.4, up by 0.2. 1.4 to 1.6, plus 0.2. Those are all the same, so I'm picking C. Over here, 1 to 1/2, if I subtract them, I'd get 1/2. 1/2 to 1/3, if I'd subtract them, I'd get 1/6. I can tell I'm different, so I'm done. I'm not picking D, so I'm not going to pick that one. Again, if you weren't sure what to do here, what you want to do is just choose the 2 of them that you want to look at and then subtract. So 1/4 minus 1/3, let me put minus signs here, which would be 3/12 minus 4/12, which is negative 1/12. So if I wanted to find this one, it would be negative 1/12. Again, that's still different from the others, but if you weren't sure, remember, you always just want to subtract the one that's on the right minus the one that's on the left. That's how to figure it out. For 12, write the first 4 terms of the sequence, defined by our piecewise sequence. So we've got our recursive sequence. Our recursive sequence says we're going to start here at 5. So the first one's 5 because we have to start at 5. And then the instructions here say subtract 5 every time. So to get the next one, I have to do my original 5, then minus the blue 5. 5 minus 5 is 0. But the instructions say just keep repeating. 0 minus 5 is negative 5. Just keep repeating. Negative 5 minus 5 is negative 10. And that's the first 4 terms, so I'm done at that point. So that's it. That's all 4 terms. So all about knowing the structure of the sequence. Find the sum of the arithmetic sequence from 4 to negative 56. And it looks like here we're counting by 3s. We're going down 3 every time. So since we're going down by 3 every time, we know D is negative 3. Since we're starting at 4, we know that the first term, A sub 1, is going to be 4. Now, the tricky thing with this is since we have to find the sum, we kind of need a little bit of extra help. We got a couple ways that we could do it. First thing is we could go recruit our friend. Since our friend is very friendly, let's see what we can do with our friend Sigma here. So sigma for I equals 1. We know the equation because that equation is going to be just 4 for A1. And then always going to be plus, in this case, I minus 1. Not an N because there's just an I over here. Times negative 3. But we still don't know N. We still don't know how many terms are in the sequence. So let's go over here and let's see what we got. We got the last term, which we don't know what term it is, but we do know that's A sub n. So that's okay. We can actually use that. Because remember, our formula in the original formula equals A sub n. A sub n equals 4 plus n minus 1 times -3. Remember, that's what our formula is. But now we know a sub n. We know a sub n is -56 because a sub n is going to be the last term in this case. We're going to find out what n is. To make things a little bit easier, I think I'm going to distribute this -3 to both pieces. So we get 4 minus 3n plus 3. We'll combine some like terms. So 4 plus 3 is 7 minus 3n. We can subtract 7 from both sides. So -63 equals -3n. We can divide both sides by -3, and that's going to give us 21 equals n. And that actually is our number that we want up here for sigma. So if we want, we could let sigma take care of this for now. Let me bring up Desmos, and why don't we throw this in? Let's see what sigma can do for us. So we're putting in our sigma. So to get there, let's go to our functions, our miscellaneous, and this is how we can get the sigma over here. Now you can see in Desmos, it does want n. It doesn't like I, it likes n better. They're just letters, so we'll put it in for n. So we don't have to do the i's with Desmos, but 4 plus n minus 1. I want parentheses around that. 4 plus n minus 1 times -3. And it looks like our good friend sigma is going to tell us the answer is -546. Okay, I mean, I trust sigma. Sigma's our friend, so -546. And so that's kind of it. If you don't trust our friend, you don't have to trust our friend. You don't have to trust sigma. There is another way that we could do it. Remember, we have the sum formula. We have the S sub n equals, I want to put n out front first, equals n times parentheses. We're going to divide by 2. A sub 1 plus A sub n. Now we can see, even if we wanted to use this formula, we still had to find n. So we still had to do all this work over here to get n. We're not out of the woods. We can't just skip over this part, unfortunately. We still need to get n. We do know n is 21, though, so we found n was 21. So S sub n is equal to 21. And then times, well, A sub 1, that's 4. A sub n is -56 over 2. We got to simplify a little bit. So this is going to be 21. 4 minus 56 is -52. All right, well, 52 cards in a deck, so that's going to be times 26. Because half a deck of cards would be 2 suits, or 26. All right, well, 26 times 21 is the same as 26 times 20, or 520, -26, sorry. Plus another 26, because we have to get 21 copies of 26, not just 20. And we get to 546. And again, since it's negative, we're going to go ahead and make it negative. So even if we didn't trust our friend sigma, we can still do it mentally. We don't need a calculator if we don't want a calculator. We can still do it. We get -546 both ways. So again, you've got your choice. You can either use the sum formula, which is kind of nice, or you can use our good friend sigma if you want to continue to see our good friend sigma. All right, cool. So that's number 13. For 14, very similar to number 13. So we did a couple questions like this. We did one as practice. We also saw one from one of the homework questions. But in a theater, there are 20 chairs in the first row, and each row has 4 more chairs in the previous row. There are 15 rows. How many chairs are there in the theater? So we know that there's 20 chairs in the first row. So this is our A sub 1. We know we get 4 more chairs in the previous row. So 4 more, that's a rate. So that's going to be D. It's like the slope. And we know we have 15 rows. So they actually give us n in this case. So the missing piece of this one is actually going to be A sub n. Well, our good friend doesn't need A sub n, right? Sigma just says I equals 1 to n of A sub 1 plus I minus 1 times d. So we could just use our good friend sigma and be done with it. I think that's going to be the play here. So let's go and bring sigma back. I'll just restart the whole process just so you can see where it comes from again. Functions, miscellaneous. There's our good friend sigma. We're going to go from 1 to 15 rows. The first row is going to have 20, n minus 1, and we're going up by 4 every time. 720 seats. Looks like we're good to go. So we get 720. We did it. We did it with our good friend sigma. Sigma has saved us. And we're done. That's it. We've got the answer. Now, if you don't want to use sigma, you don't have to. Again, you're going to have to go through kind of the longer process, though. That's okay. We have to use our formula a sub n equals a sub 1 plus n minus 1 times d. Because we know some of this information, right? We know n, a sub 1, and d, so we can solve for a sub n. So a sub n is going to equal, just like we've got over there, 20 plus, we'll do parentheses and minus 1. But we actually know n, right? N is 15. D is going to be times 4. So we can solve this. We can find out how many seats are in the last row. So we're going to get 20. And I like to distribute, so I'm just going to distribute this 4 while I'm here. 15 times 4 is 60. 4 times negative 1 is minus 4. Oh, that makes it nice, because 20 plus 60 is 80. 80 minus 4, that's 76. So I know a sub n is 76. But now that I know a sub n, I got another formula to do, right? I got to do s sub n is going to be n times parentheses a sub 1. A sub 1 was 20 plus 76 divided by 2. I wanted to do the formula first. Let's not plug in yet. Let's just write the formula down. A sub 1 and a sub n. All right, now let's fill them in. So s sub n is equal to, n is 15 because we've got 15 terms. A sub 1 is 20 because we're starting at seat 20. 20 seats in the first row, 76 seats in the last row. Divide them all by 2. 20 plus 76 is 96. That's 4 away from 50, or 4 away from 100. Half 100 is 50. Half of 4 is 2, so we get 15 times, we'll just say 50 minus 2. 48, but 50 minus 2 is going to be a little bit more useful because, again, we got to distribute. So we can do 15 times 50, 25, 750. We need to subtract 15 times 2, so minus 30. We get 720, and without a calculator, we still got the same thing that we got when we used sigma. So we still got to the same answer. A lot more work, but that's because we didn't use our friend sigma over here. All right. 15, use a graph to solve x plus 3 minus 1 equals x plus 2 squared. Your graph will be scored. So that means we want to be somewhat accurate with our graph because we are going to be scored on our graph. If you're worried, you can graph it in Desmos or your graphing calculator and copy the graph. But I do want to see the graph. So let's see, x plus 3 minus 1. If I use my shifts, since I'm inside here, that means we're going to go to the left 3, 2, 3. We're going to go down 1, and then absolute value is the V shape. So since I want to be super accurate, I'm actually going to use my line tool since I know my graph is going to be scored, and I'm going to go with the slope of 1 for a V. On this side, same deal. Oops. All right, slope of 1. All right, so I want to be really accurate with that one. So that's this side of the equation. That side's all good. I'm going to underline that in black because I decided to do it in black. I'm going to move down 1 over a little bit because I've got one other shift I got to deal with, and that's in my x plus 2 squared. This is a shift that's going to go to the left 2. 1, 2. I'm not going down at all, so I don't need to go up or down. I'm not adding or subtracting anything. And I know this is an x squared. So x squared is going to be a parabola. So up 1 over 1, then over 2, 2, 3, 4, because 2 squared is 4. And we'll try and make a nice parabola. That's looking like a somewhat quality parabola. I've done better, but that's gonna do for right now. So the idea here is now I've got my graphs. So where it says my graph will be scored, that's good because I got my graph. Now I have to actually do the other part, which is to solve. Remember, when we're solving with a graph, it's the two intersections. There's no x's in here, or there's no y's in here. There's only x's. So since there's only x's, if I were to write a y coordinate, it would be wrong. So since there's x's only, my answers are just going to be the x values that the intersection's at. So right here is at -2, and right here is at -1. Those are my answers. How do you lose credit? Well, you lose credit if you put down the wrong answers. These are the wrong answers. Wrong answers over here would be x comma y points. Those are wrong answers. Those are not the answers that we want. So if you write down -2, 0, that is a wrong answer. Even though that's what that point is, there's only x's up here. If you write down -1, 1, that is a wrong answer. Even though that's that point there, only the x coordinates, because we only have x's in the equation. For 16, another graph. So use the graph to solve 2. Absolute value of x plus 1 is greater than or equal to 3x. Again, your graph will be scored, so we got to be careful again. But when we do these inequalities, remember we write them 2. Absolute value of x plus 1 is greater than y. We'll put the y right afterwards. Since I'm graphing it by hand, I am going to flip it around. You don't have to do this if you're going to use Desmos, but you do if you're using your TI calculator. So we have to remember that we're going to flip this one around. So using my shifts, I'm not going left or right at all. I am going to go up 1. So I got to go up 1. And I'm going to do a stretch of 2 vertically. So with my vertical stretch of 2, again, I'm going to be somewhat accurate. Let's use this one. Can I use that one? That does not look good at all. All right, back to the regular one. But we got a slope of 2. So we're going to go up 2 over 1, up 2 over 1. Over here, up 2 over 1, up 2 over 1. So right there. I'm going to make them blue just because I want them to be blue. And they are solid. So again, note that we've got the or equal to sign. That tells me that I've got to be solid. All right, so next I got to shade, because with the inequalities I have to shade. So the nice thing is when we put the y on the left side, I can tell that I'm just shading down. So we're going to shade down. So I'm shading everything that's below there. So that's it. That's what that one is. Now I got the other side, though. So for the other side, I've got 3x. So I want to write that one as y is greater than or equal to 3x. Now I don't need to manipulate this one at all. It's already set to go. I know it's solid again because I've got the little or equal to sign. That's one of the nice things about this is both of them are either going to be solid or they'll both be dashed. And that's just a regular line. So it starts at 0, 0 because it's 3x plus 0. So the y-intercept is 0. I'm going to go up 3 over 1 for the slope. Up 3 over 1 for the slope. Down 3 back 1 for the slope. I'll make my line. Go like that. We'll make the line red. Oops, wrong button. We'll make the line red. Now I've got the red line. And with this one, we have a y is greater than. So we need to be above the red line. So for the red, we have to shade over here. We're going to keep shading over here. We'll shade over here and this little section over here too. And so the answer is everywhere that's double shaded. Now, it might be a little tough to see on my graph, but this section over here counts as double shaded. So all this little crevice right here is double shaded. And then everything that's like over here is also all double shaded. So this all counts as solution 2. I gotta be careful. I don't want to go past that blue part. Let's get rid of that purple. There we go. So all this would be the double shaded section. And that's it. So when it says use a graph to solve, your graph will be scored. So I've made the graph. The graph is good. Now I need the solution. So remember, the solution is the double shaded part, but only the x's. So again, I'm only going for the x's. So I can see the furthest that I'm coming from is down here at negative infinity. Like there's purple, there's double shaded at negative infinity. So we can go negative infinity. And as we traverse, the farthest right that we can go is this little point all the way over here. Because there is a solution up here. So I can go all the way until I get to here, and then I have to stop. So I have to stop once I get to 1. So this is the answer. So those are all the parts that I need. So I've used my graph to solve it. I got the graph. It looks nice. Well, maybe. And it looks kind of squiggly. But I got my graph. It looks complete. I've got my solution. My solution's a domain. It's just the x values from negative infinity to 1. All right, for 17, solve the system of equations. You can do this however you want. I'm guessing most people will choose to throw these into Desmos and find their intersection. If you don't want to do that, this one's not too bad to do by hand. If we switch all of these signs and then add them up, 2x minus x is x, negative y plus y is 0, 7 plus negative 10 is negative 3. I've already got the x coordinate. I can take the x and then plug it into the original. So x minus y, not x, x minus y equals 10. I know x is negative 3, so negative 3 minus y equals 10. Add 3 to both sides. Negative y equals 13. Divide by negative 1. Y equals negative 13. And we can just double check, just make sure it fits. 2 times negative 3 is negative 6. Negative 6 minus negative 13, so negative 6 plus 13 is in fact 7. So we're good to go. Write it as a coordinate pair and call it a day. Again, you're more than welcome to graph that and find the intersection in Desmos if you want, or your graphing calculator. 18, write a matrix that represents a system of equations. Again, you're just doing a coefficient matrix, so all you're doing is looking at all the numbers that you have. Remember, these have all coefficient of 1 in front because there's no number there. So the numbers that are there are 4, and then negative 1, and then 2, 1, and then 1, and then negative 5. Make it look like a matrix. And you can even put the nice little line there because it's an augmented matrix. And that's it. So you're just grabbing all those coefficients and you're taking these numbers. And the nice thing is it should look a lot like what you have in number 19. If it doesn't look like the other matrix on the test, something's probably wrong. So use the structure of the test to help you out. Speaking of 19, we get to do reduced row echelon form for the matrix. This is basically a calculator question. We just want to RREF this thing. So again, you can throw that into your TI calculator. If you're using the Desmos matrix calculator, let me bring that up and we'll try throwing it in there. So to do that, I want to do a new matrix, matrix A. I've got 3 rows and 4 columns. Don't know any of my numbers, so I got 1, 1, negative 4. 4, I think this one was 303. And we got 2, negative 1, 0. I didn't even look to see what the last column was. 1, 4, negative 12. 4. All right, we locked that in. So we're good to go. All right, cool. Do I hit new matrix? I don't hit new matrix. Clear that matrix. Perfect. So what I want to do is I want to RREF that one. So I'm going to do RREF of A, and it's going to give me my solution in RREF form, row reduced echelon form. Cool. So my numbers are 3, 0, and negative 1. RREF is nice because it's always going to be 1, 0, 0, 0, 1, 0, 0, 0, 1 for 1x, 1y, and 1z. And I forget our numbers. 3, 0, negative 1. So the solution to our system would be if we wanted to actually write the solution. X is 3, y is 0, and z is -1. And that's pretty nice. A pretty quick way to do those 3D systems of equations. All right. Last one, number 20. MRE is using row operations on the augmented matrix representing system of equations and obtain the result below. How many solutions does MRE system of equations have? So MRE systems of equations says that 1x equals 4. Well, let me write it as 1x plus 0y. Let's make the zeros have meaning. Equals 4. And 0x plus 0y equals -3. Well, from the top equation, that's pretty nice. I can tell that x equals 4. But from the bottom equation, 0 times x is 0. 0 times y is 0. We get 0 equals -3. But this is false. That's not a true statement. So since it's false, we have no solutions. No solutions would be 0 solutions. The problem is solved. For some reason, just didn't register 0 as no solution. But yep, there are no solutions to this one. So it's A.